Okay, today we've finally arrived at the end of our last lesson. This is the end of Module 2. Okay, there were 29 lessons all together, and we have reached the end. And today we're going to actually do the same thing that we did yesterday. We're going to take a look at how we can use tape diagrams to help us understand and make sense of word problems. Because for those of you who did practice at home, do you agree? The hardest part of these word problems is understanding what they mean. Once you understand what in the world they're talking about and what they're asking and all the important information and what it actually means, it's actually not that hard to solve it, right? So drawing tape diagrams really helps us to make sense of the problem before we solve it. Okay, Haley, what's the question asking us?
How many weeks will it take her to save enough money for the trip?
You got it. We're trying to figure out how many weeks Michelle needs to save up so that she can make it to the trip, okay? So she can get $150. Take a moment now to write a number 2 and all the important information we need.
$50.
Altogether, she's trying to save $150, okay?
And she saves $12 each week.
Okay, and she saves $12 each week. Very good. Does anyone remember back to yesterday? What's the first step in solving a word problem?
Make a tape diagram.
It starts with M. Yeah, make a tape diagram or model. Good. They both start with M. Good. Okay, so all together, how much money does Michelle need? $150. You got it. Okay, so the whole dollar amount, the entire piece of tape, is worth $150. After 1 week of work, how much has she earned? $12, right? After 2 weeks of work, she earns another $12. So how much has she earned altogether? $24. After 3 weeks of work, she earns another $12. And how much dollars has she earned altogether? So do you see how we would keep doing this until the last $12 gets her enough money to go? Right? And each chunk is $12, yes? Okay. So we want to see, do you guys see how we're trying to figure out how many chunks of $12 fit into the whole piece of tape of $150? So what do I need to do? 150 divided by 12. Think back to when I talked about grouping and sharing. Are we sharing $150 equally? Or are we seeing how many groups of $12 fit? So is this a sharing problem or a grouping problem? Grouping, you got it. Okay, so today, a lot of them are going to be grouping. Okay, so can we do 150 divided by 12? We sure can. Let's go ahead and set it up using the standard algorithm. Which number is the whole? So which one lives in the house?
150.
A very, very common mistake for 5th graders to make is they get the whole and the divisor mixed up. Okay, and of course the divisor is 12. Now, remember, what was that trick I just told you guys? What could we do? We can write out the skip counting for the divisor. Okay, so what's our divisor? 12. Let's write out some skip counting. 12 times 1 is? 12. Then? 24. Then?
36.
Then?
48.
Then?
60.
Then?
72.
Then?
84.
Okay, let's stop there. Okay. Again, this really helps because you can refer back to this over and over again and you don't have to keep doing guess and check, right? Okay, what's our biggest place value in our whole? Hundreds. How many hundreds do we have?
1.
Can we divide 100 equally into 12 parts?
No.
So let's regroup it. Then we have 15 tens. Can I share 15 tens equally into 12 groups?
Yeah.
How many would each group get?
1.
10. Good, so let's put a 1 in the tens column. Then we can do 1 times 12 is?
12.
And when I subtract, what do I get? 3. 3 whats?
10.
3 tens. So I can regroup that and bring down the 0 ones to have a total of how many ones?
30.
Now looking at our skip count over here, what's the closest number that is closest to 30 but doesn't go over 30? 24. And what row is that in? 2. So that means 12 times 2 is 24. So let's put a 2 up in the ones column. Then we just know already that 2 times 12 is 24. And what do we have left? 6. So the 6 is in what place value? Ones, which means we can regroup it as 60 whats?
10.
Okay, do we have 60 somewhere in our skip counting?
Yeah.
Yeah, it's in what row? 1, 2, 3, 4, 5. That means that 12 times 5 is 60. So what number should we put in the tens column?
5.
Okay, and then when we multiply it, we get 60 and a remainder is 0. That means that Michelle needs to work 12.5 weeks. Now, if she can't work half a week, how many weeks? If she works only 12 weeks, will she have enough money?
No.
So how many weeks does she need to work? So the answer is 13 weeks. Very good. So what is the important information that we need then? Jitya? Altogether, Tyler baked 702 cookies. He sold them in boxes of 18. He sold each box for the same amount of money, okay? And altogether he earned? Yeah, okay, so we're trying to figure out the cost of one box of cookies based on all this information. So let's start with what we know. How many cookies did Tyler make altogether? How many? 702 cookies, good. And he divided them into boxes of how much? 18. So if there's only one box, he has 18 cookies in here. Does he have enough for another box?
Yeah.
Right? Okay. Does he have enough for another box? And he's going to keep boxing them until he runs out of cookies, right? Even the last box of cookies needs to have 18. So how can I figure out how many boxes of cookies he has altogether? Stella? Right, to figure out how many boxes, I have to do 702 cookies divided into boxes of 18. And this will give me how many boxes he made, right? Okay, go ahead and figure that out. Based on our division here, we can see that he made 39 boxes of cookies. Going back to what we underlined, we're trying to find the cost of one box of cookies. So we have to draw a new tape diagram now, okay? If I know that he made 39 boxes and all together he earned $136.50, that means that all together he earned $136.50. How many boxes was that split evenly by? 39. So you have to split it like this, right? And show that this is 39. 1, 2, 3, 4, 5, 38, and 39 boxes of cookies. Yes? Yep. So how can I figure out the cost of just one box of cookies? Jitya? By 34. Or 39. Sorry, I didn't write it very clearly, but 39. Right? Because there's 39 boxes altogether. Does that make sense? Try it out. Write out your skip counting and see if you can divide 136.5 divided by 39. When we finish this problem, we can see that each box is sold for $3.50 because we take the total amount that she made, which is $136.50, and split it evenly by the 39 boxes. This second part of the problem, is it grouping or sharing? Do we already know the number of groups? How many groups were there?
Sharing.
So it's sharing. The first problem, was it grouping or sharing? Okay, so you can see how division can be both. Here we can see that because the length is 4 times as long as the width, if one rectangle is the width, then the length would be 4 of those rectangles. Yes? Okay. Now we also know that the area or the distance around the entire park is 12.5 kilometers. Think about what you know about the distance around. If this is the width, is that the same width over there? Yeah. If this is the length, is this the same length over here? Yeah. So how can I find the total distance? How many widths are there? 2. And how many lengths are there? 2. Okay, so let's see if we could draw that out. Here's one width, and here's another width. Do you guys agree?
Yeah.
And then if I was going to draw the length, here's one length, and here's another length. Yes? Yes, do you guys agree? Yeah. Okay, this is the length, and this is the length. All together, that total distance around the park is how long?
It's
12.5 kilometers. Could I rewrite this picture down here all using widths? I could, right? Because I could just take this length and divide it into how many? 4. And take this length over here and divide it into 4 too. So if I do that, how many widths are there all together?
10.
Count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how can I find the length? How can I find how long one width is? I could take 12.5, the total, and divide it by 10, right? Would that tell me the width? Yeah. Go ahead and do that. Okay, we can see that the width then is 1.25 kilometers. Once I know the width, how can I find the length? Multiply it by
4.
4, good. So the length will be 1.25 times 4. Okay, we can write it in standard algorithm or we can break it up into parts. Can we do 1 times 4?
Yeah.
What is 1 times 4? Okay, so first we did 1 times 4. And now we're going to do 0.25 times 4. 0.25 is the value of a quarter. If I have 4 quarters, how much do I have? $1. So what's 0.25 times 4? 1. So 1.25 times 4 is the same as 4 plus 1, which is? 5. So which one's the right answer? 1.25 or 5? None of them. Why?
Because that's all.
What's the question asking?
The area.
So how can I find the area now that I know the length and the width?